I'll get coached to do just so we're aware.
And I'm going to talk to you today about 3D printing. So whenever I tell anyone that I've been involved in projects to do with 3D printing or that I know anything about it whatsoever, I always get asked the same questions. So I decided to present this as Shauna's 3D printing frequently asked questions. So your first question is, who is this girl anyway? Again, you can't pronounce her name, so you can pronounce the first name maybe, but you can try and pronounce the second name. I'm a trainee medical physicist at Clyde Cancer Centre, so I'm doing the NHS scientist training program. Basically, I work in radiotherapy, and we do all the QA, we do lots of kind of research work, we do lots of treatment line type stuff. Yeah, I love my job, I love collaboration and everything. So to get into that, I did a BSc in physics with medical physics, and then I did that in Ireland, Galway, and then I did an MSc in medical physics, and that's where I got my background in 3D printing because I did a project in a hospital that was based on 3D printing, which I will tell you about later on. And now, as part of my training scheme, I'm in the final year of 3 years. I'm doing another part-time MSc in clinical science, and I'm about to start another project in 3D printing because the hospital I'm in now heard that I could do it, and yeah. So once you start, you can it never ends. This is a really cheesy photograph of me wearing a white lab coat. I was in Canada recently doing a little placement in the hospital there, and all the doctors, physicists, everything, all wearing lab coats like Grey's Anatomy style, and I thought it was great, so I took a selfie. So outline. So what is 3D printing? I'm going to tell you about what it is. I'm going to tell you about how it works quite briefly. I'm only going to speak about fused deposition modelling, which are big world words, which I will explain. There are lots of other types of 3D printing which vary in speed and accuracy and things like that. But I'm just going to talk about the basic one you hear about all the time. I'm going to talk about what I've done personally with 3D printing. I'm going to talk about what it's used for in the whole world. So it's used for so many things, but I'll give you a few brief ideas of things that it's used for. And this last question I want you to think about for yourself. What can 3D printing do for you? I'm going to ask you that question again at the end, and you can volunteer answers, although I don't expect any of you to speak up. But if you did, that would be great. So what can it do for you in your own personal life, in your working life? So just have to think about that as we go through. So what is 3D printing? You might have heard it referred to as additive manufacturing or rapid prototyping. So it was invented back in the 1980s, and it's being used a lot since then, but more so in the manufacturing world. It hasn't been in the public eye as much. It's just in big companies. They're really expensive. But it was also called additive manufacturing, and that's kind of the umbrella name. 3D printing is kind of like a buzzword at the moment, kind of like cloud computing or these other words that you hear. So you create 3D objects by laying down one layer at a time using a computer-controlled device. So if you can imagine your ordinary inkjet printer, it doesn't, when you print on it, it doesn't dye the pages. It actually just lays down a very, very thin layer of ink on top. So if you put the same sheet through a printer like 1,000 times, eventually those words will start to build up, and it actually would work as a 3D printer. So this is exactly the same idea as normal inkjet printing, but instead we're using something like plastics or metal to build a 3D object one layer at a time. It's the opposite to milling. So milling is where you take a big lump of something, like a big lump of wood, and you cut it, you mill it down, remove pieces until you get the shape that you want. But that's quite wasteful, whereas 3D printing, you're building up exactly the shape you want. Not make an effect, so it's not wasteful at all, and you can do some really cool stuff with it. And finally, this is STL files. So STL files are, you take a 3D file, and you have to slice it, and that's that sliced file that the printer can understand. It's like STL actually stands for Standard Tessellation Language, if you want the lingo. But basically, it's a sliced 3D object that can print it themselves for time. So how does it work? So I've done a little flow chart, which I hope you can understand. To start, you need your computerized 3D model, and you can make this yourself in CAD, which is really fun thing to do. You can build up any kind of shape that you want, and you can use a 3D scanner. So I work in healthcare, 3D scanners that we tend to use are always CT or MRI images. But you can also get, if you have like an Xbox Connect, that's a really good infrared 3D scanner. You can buy infrared 3D scanners. And finally, there's lots online. You can go to, I think it's called Thingiverse, and you can just download whatever it is that you want to print. And there's so many online, because when people make something in CAD, they tend to put it online, and that's great. So there's lots of things you can print, download straight from your machine. So next you have to slice it. It's not already sliced, so you just convert it to an STL file. Quick and simple. The software to do that usually comes with a printer. You can download it off GitHub. Then you send your STL file to the printer, either plug in your laptop, use USB, send it to the cloud, whatever you want to do, so that the printer has it. You have to supply the printer with a filament, which is the ink of the 3D printer. And then what happens is your nozzle, which is going to extrude the filament, it goes to its starting point. It heats up the filament to melt it, and then it moves around, layering it down in kind of like a flow, and you get like a layer, a thin layer, which is your starting layer. And once that layer is complete, it just goes back to the starting point of the next layer, and it does it again, and it builds it up, and you can make all sorts of amazing shapes of it. And here, I don't think it's that really well, it's like a bus stream in 3D picture, which is really cool. So what kind of filaments can you use? So you can, for a fused deposition model, you can use anything that becomes liquid and melted. So that is a lot of things. Most people use plastic, PLA or ABS, with here would be like PLA filament. So they're the types of plastic, and you can buy them really, really cheaply on the internet. If you order them, especially if you order them from abroad, you're talking like £20 for 40 meters of filament. So you get loads of that. It's amazing. You get all different types. You get types that change color when they heat up. You get types that are flexible. You get types that do like under UV light change color, all that kind of stuff. So you can get really cool plastics. Then you can print in metals, you can aluminium, steel. If you have like a heavy duty enough printer, you can print a lot of things. So they do that in the industry a lot. You can print with precious metals. So 3D printing jewelry has become really popular recently. So you can print in gold, silver, bronze. You can print in ceramic, you can print in nylon, you can print clothes. You can even print with multiple filaments. And if you have a look at this photo down here, you can tell that you wouldn't possibly ever be able to print this by itself, because it would kind of fall over and you're trying to print it through its thin air. So you print with two different types of filament, and the other one, in this case, it just breaks off. So you print it with that extra filament, break it off, and you're left with the shape that you want. But you can also get those types of filaments that if you dunk them in water, they'll dissolve, or in a solution that they'll dissolve. So it's really easy to get these amazing shapes that kind of almost defy 3D printing, floating in air and stuff like that. So if you use two filaments. So what else should you consider if you're considering buying a 3D printer or doing some 3D printing or anything like that? You need to think about the print speed. So lots of things will change your print speed. If you try and you can control what speed something prints at, but if you try and print something really quickly, it will like warp and it won't come out very nicely at all. So a lot of the time, for the first few layers, maybe 4 or 5 layers, you do a really slow print, just to get like a good base, so there's no warping and it's sitting on like a firm base to begin with. But there's other things that affect printing speed as well as that. For instance, infill. So if you look at this little picture down here, you have 50% infill, 20%, 50%, 75% infill. So that's the amount of space. So a lot of the time when you're creating something that doesn't need to be that sturdy really, or doesn't need to be heavy or anything like that, you can print it with a lower infill on the inside, and then on the outside have full infill, which is what we can see here. So the object, when it's finished, if the bottom layer, top layer, and all of the side layers are all full infill, it looks like it's completely infilled, but it's a lot faster to print. So infill is a really interesting thing to talk about, because it works physics. They almost always have to fully infill them 100%, and so those prints take a really long time. But if you were just printing things like these people owls, then you could do them with partial infill. you need to consider the maximum print size, so you're always limited by the maximum print size of your printer. The printer I used to work with had 20 by 20 base, so 20 by 20 was the maximum size that you could print anything. So you do need to consider that if you're thinking about buying one or anything like that, or thinking about designing something for your printer. Using multiple filaments, which I spoke about earlier, is a really good way of supporting your build. Are you going to have a heated printer bed? So heated printer beds are really good because you can imagine if you put hot filament down, which is kind of extruding from the nozzle at 180 degrees, and putting it onto a cold bed, it dries really quickly, and you get that warping effect. It curves on the bottom, it dries and contracts. But if you have a heated bed that's heated to 40 degrees, it sticks really well, and it doesn't cool down too quickly, and that gives you that nice flat base that you want for any print that you're going to do. So heated printer bed, I would never recommend anybody to buy a 3D printer that didn't have one of those. You can do multiple objects in one print. So if you look at these little owls over here, all of those are being printed at the same time. It prints the base of one owl 1, owl 2, owl 3, and then it prints layer 2 of 1, 2, and 3 as it goes along. So you get to print 3 things at the same time on the bed. The only issue with that is, if the print goes wrong, you lose all 3 objects, which, that's a risk you take if your printer malfunctions. But it's a really good way to get things done quickly. And then if you're printing multiple objects, you can also print in parts. So if you can imagine you were trying to print a globe, that would be really difficult to do because you need a flat part on the bottom or else it would fall over really easily. But what you can do is split it into 2 hemispheres and print them both flat, and then just stick them together at the end. And you can do that with most objects. If they're too big, you can print them in smaller parts, and then you have to get there again. And then you also need to think about things like nozzle cleaning, calibration. Nozzle cleaning can be really difficult if you really need to take care of your nozzle, or else it's just, it's not good. And then calibration, I used to calibrate mine every day because we're using it for scientific stuff. But the more frequently you calibrate, it's better. If you buy a really high-tech 3D printer, you want to calibrate it often, and that's great. But if you're buying one that's quite good value, then you don't have to calibrate it. That's kind of consuming, but it's something to consider. So what did I use it for? I created bolus material for radiotherapy using a 3D infrared scanner, that you can see here, and my 3D printer, which was a RepRap Pro, which is a really good value printer, which the hospital just bought as kind of a tester to see what they could do in the future. So basically I was scanning people's noses and ears, and I was creating molds of those, and we use them in radiotherapy for skin cancer patients. I won't go into the details of volumes and things like that because it's all to do with dosimetry, and I don't want to get into it, but basically we wanted something that conforms to structures really, really well. We don't want any air gaps in there at all, because of the way that the radiation behaves. So it really had to fit really well, and you want it to be comfortable for the patient as well. You don't want something that's a jagged plastic sitting on their ear or whatever it is. So the poor guy that I shared the office with that summer got 3D scans every day, and this is his ear, which I printed. So this printer, although it had to be calibrated every day, it cost €500, so really cheap. It had to be calibrated every day, but the prints were really accurate on it. Once you got it right, it's great. So I commissioned and calibrated the printer. I printed ears and noses because they're small complex structures, and that's what we're looking to see we can do. I tested different materials, and actually the material that I found, so we're looking for a material close to tissue density, because for dosimetric reasons. And we found this material which is called NinjaFlex, which is really cool. And basically, you can kind of print like a bouncy ball with it. You have that flexibility, but it's still kind of rigid, if you know what I mean. It has that spring to it, and that would be perfect for something like these kind of ear molds, because it's going to be quite soft on the patient rather than being this harsh plastic sitting on them. And I did density and accuracy measurements on that as well. So this is kind of some of the stuff that happened. So the nose looks really good from the front, but as you can see on the inside, and that material that we used before we found the NinjaFlex one, it's really jagged on the inside. That's not very comfortable. And then here we can see a print that went wrong. And this is the kind of thing that happens. You kind of leave your 3D printer and go and get lunch and come back, and this has happened, and you don't really know why. So that's the kind of thing when something goes wrong that can happen. Here, this is one of the color changing movements. So because we were looking to not have any air gaps, and we had this idea, if we bought a material which changed our body temperature, then we could fit it onto the patient, and if any spots were still green when we took it off, then we know that it wasn't well fitted, and that would save us having to CT scan the patient and give them that extra dose of radiation by scanning them and having to rescan them and things like that. And this is sort of keep image flex that we had. Part of my printer melted, and I was not the one who assembled the printer, it was an engineer who assembled the printer, and he put one piece on backwards. And obviously because the extruder was being heated to 200 degrees in some cases, part of it melted, and it was a disaster. You can see here where we tried to fix something out of wood together to try and make it work. But what actually happened is I ended up calling up someone else in the city who had quite a good 3D printer. It was a company, which I'll tell you about later on. But she printed in her lunch break, in 20 minutes, she managed to print me a new piece, and it came out perfectly. And the interesting thing about a lot of these printers that you buy is that a lot of the printer itself is 3D printed, and so that means that they recommend, they're like, once you have your printer for 6 months or something, you should print all the spare parts, and then they're there ready to go, because if you wait until the printer breaks, then you'll have no printer to print the spare parts. So you should print them first. Obviously, I did not do that, so our printer melted, and she made us this little part, and it worked perfectly. So these are some of the stuff that I use. I kind of wanted to put these in because I just wanted to show how easy it is to make up something in CAD to do a little experiment on if you need to. So I just, in CAD, put this together. These are TLD chips, so thermal luminescent dosimeter chips. And I just wanted to make up something so that I could put it in the CT scanner, do a little bit of treatment plan stuff on it, get densities and things like that. But the TLD chips had to fit perfectly into this phantom. And I was able to do that like in half a day. It was so quick and so easy, and that's what they're great for, just whipping something together and saying, oh, I'd really like to have this, and just being able to do it straight away and so easily. And so that's what, I thought I'd throw these in because it looked kind of cool. So that's what it looks like when it's CT scanned and treatment planned. And so we have how we found our density and stuff for it. So that's what treatment planning software for radiotherapy looks like. So my current project, which I'm about to do, is very similar. And we're going to use try and 3D print one of these. So this is a hand applicator, and it's for treating skin cancer of a thumb patient. And basically we're going to use tiny radioactive seeds, and you have to travel, they're very high dose, and you have to travel through these little tubes, sit there for a second, and then go back out. So the physicists, or the radiotherapists, they set the patient up, they leave the room, they press go, they go out themselves, and then they come back in because it's such a high dose. But the main issue is if the sources get stuck, that's really bad, because then someone has to go in and take it out, and they get a high dose, and they're not the ones being treated, so that can't happen. So it really does need to be accurate, and right now they just make it up by hand. They just make up this cast by hand, and you just the tubes and go into it. And they do a good job, but it takes a week to do, and it's not efficient at all. So we're trying to improve that by using 3D printing. So that's what my next project will be. I'm doing that with the University of Liverpool and Cambridge. So what is 3D printing used for? It can be used domestically, and they say sometime in the future, if your toaster breaks, you'll just print another one. Or if a part of something breaks, you could just print another one. And it's so good for so many applications in the home. I think in the future that we will see people downloading the STL file for like a certain object and just printing it for their home, which would be really cool. It's used a lot at the moment in manufacturing, apparently especially in the automotive industry, but in lots of different industries they're 3D printing things. It's really good for printing prototypes. So the great thing about 3D printing is it's not really that efficient if you want to print a million of something, because you might as well just mill it. But if you want to print one individual thing that's really specific, and you only want to print one of them or 20 of them, it's brilliant for that, because you don't need to create a whole process to do it, you can just print it, which is great. So it's perfect for prototypes, and that's also why it's so useful in medicine, because every body is completely individual and completely different, and when we're making devices for the body, they need to be fitted to that person, and that's why it's good for that as well. So prototypes, cloud computing, 3D printing. So you can imagine if you're someone who's thinking of supply and demand, you're thinking, oh, we need to have 100 of a particular product in China by tomorrow. Can you imagine if you could just log into your laptop and just fresco, or they would be printing in China. So there's no need to make them in one country and ship them to another. You can print them in the country that they need to be in. So that's why Plasma and doing 3D printing together are such a good combination. NASA uses an awful lot of 3D printing. They recently put a zero gravity 3D printer on the International Space Station, which is really cool. And that means that they don't have to take up, they used to have to take up a spare part for everything on the International Space Station. And they used to have to take up all the tools in case anything broke, but now they don't have to take anything with them. It's much more lightweight. They just print what they need. They have the material there. 3D printing of food is also something that NASA is very involved with for the astronauts up there, because they're eating like paste and things, and they want them to be able to eat solid food because that feels more better for them, obviously. So the food 3D printing, if you look up online, there's lots of chocolate 3D printers or ice cream 3D printers, or all these donut 3D printers that you can buy, which is kind of cool. Customized products, obviously, is really great for customized products because you can make something with your name on it, and it's really cool. Education and research, it's a really good thing for getting kids or young people involved with engineering and science and things like that, because they can imagine something and it can be made in front of them, and that's really what engineering is all about. The things that you've thought of coming to life in front of you, and that's really cool. Amazing for research as well, because as you saw, my little jig that I made up in half a day, it's so easy to make up apparatus to use for experiments and things like that. Architecture, those tiny little models that when architects say they're going to build something, they make a little model and you can see what it is that you're actually going to be living in. It's really popular with them. Environmental, so the example I had of this is the coral reefs. They've been 3D printing these kind of coral type shapes, and then coral is more likely to grow on them, and it's rejuvenating coral reefs, and so that's really cool use of 3D printing. Clothing, you can see some shoes here that Adidas made, which were 3D printed. I think the top of them is like a soft nylon material, and then the bottom is kind of like a fancy rubber type thing. And they're thinking about, they're investing heavily in 3D printing, thinking about 3D printing in the future. And actually there's a company out there that makes orthopedic shoes that fit your foot exactly, and they can make them in any style that you want, so that's really nice. And toys, so you can see like the little My Little Pony type things. If you're a child size, they want a My Little Pony toy, you can just print it. Firearms, in very harsh jump there, but
sometimes.
So this was like a huge talk in 2013. Everyone was talking about these guns that were made of plastic and they weren't going to be detected by metal detectors, but in reality, actually, the guns are more dangerous to the user than anyone else if you're printing them out of plastic, because a gun is basically a small device that contains an explosion and points it in one direction. So yeah, it might work the first time, but if you use it 10 times, at some stage it's going to explode in your face. So really printing guns out of plastic may not be that good of an idea. They can print guns from metal, 3D print them from metal, but it's so expensive to do that you actually could buy thousands of guns instead of trying to 3D print one. So it's not really taken off the whole 3D printing firearms thing at all. There was a man in Japan who was sent to jail for 2 years for 3D printing a gun, and those people who put the Liberator, I think they called it, up online, the design of the 3D printed gun, I think they got in a lot of trouble as well. And now, finally, I'm going to talk about medical usage. This is the last thing I'm going to talk about. So this is my area, so it's the one I know most about. So bioprinting, so 3D printing organs. I think in the future we'll be able to 3D print kidneys. So how bioprinting works is we're not actually 3D printing tissue material. What we're doing is we're 3D printing a mold and then lining it with cells that are going to grow to fill that mold. And with stem cells and things, you can grow you can actually grow organs. They use it to print like skin a lot. If you looked at the ear that they've made, so it's perfect for printing skin. But if you want to make a functional organ, then you really need things like stem cells, which is still in pipeline. But yeah, in the future we might be able to 3D print organs. Biodegradable trachea splint. So this is a really nice story. There's a baby who was born with a collapsed trachea, and by the time she was 5, it had gotten really bad, and she was on a ventilator, and they didn't know if she'd live. And what they did was they 3D printed a tiny little support splint for her trachea. And the great thing about it was biodegradable, so they put it in, and 3 years later it was just gone. They never had to take it back out, and by that time her trachea had strengthened enough that she could breathe by herself. And she was on a ventilator, and within 3 days of getting this in, she could breathe by herself. That's a really nice story. Bony implants, they've done lots of jaw implants with this kind of thing, and especially in people who might have only lost one half of their jaw, and they can print the other side to look exactly the same using CT images. So that's really cool. And this lady here had to have her jaw removed, and they were printed back the way it was, so she kind of looked the same, which is really, really nice as well. And so models of organs for surgeons practice on. Do you remember earlier I was speaking about there was this really nice company that made me a piece of my 3D printer in their lunch break? Well, that was actually this company in Galway. And basically, when babies are born with heart defects, it's really difficult for the surgeons to tell from the CT what they're going to face when they get in to do the surgery, because it's just so small. So what this company did was it took the CT images and it multiplied them by 10, and then it printed them. So these little baby hearts are the size of normal human hearts, and they had a 3D model. You could give that to the surgeon, and the surgeons could say, "Oh yeah, okay, I'll go in this way and do this," and they'd know what they're in for. So that's an amazing use of 3D printing in medicine. Prosthetics. There's lots of wonderful cases about prosthetics about, in the medical world, but I really want to talk about this one. This is Buttercup the duck. So Buttercup was born in the US in a high school biology lab, and her foot was backwards. Her left foot was backwards, so it had to be amputated. So this company, they 3D printed the duck a new foot to match its other foot. Which is really, really cute. But not only did they 3D print the duck a foot, they put an insert onto the leg, and then they could replace the foot, so she has like a collection of feet that she can use. And if you look really closely, this is a Christmas foot. There's like a present and a snowman on there, and it's really cute. And if you look her up, she has like an Easter foot and a Halloween foot, and she lives in a nature reserve now, happily with all the other little ducks, and that's a really cute use of 3D printing. Bionic ear, so this is an experiment, so it's actually not really being used, but this ear could hear better than any human ear. And they have the technology to do it, but they don't know how to put it into the ear. So they said, instead of trying to put it into somebody's ear, why don't we build the technology and then grow an ear around it? And that's what this is. This is basically an experiment, but that's human tissue, ear, and then an electronic hearing device in it. So that's really cool. And then finally calves. You can imagine like you could 3D print calves for people, and I thought that was a really good use of it as well. They're more breathable and things like that. You use really breathable materials, so a little bit better than plaster cards, and that's really cool. So what would you use it for? Do I have any volunteers who might tell me what they'd like to use 3D printing for? I hear I have people.
I would definitely use it to, when my kids are left from kinder eggs and there's stupid toys in them, I would literally just print shed loads of those, one for every day. I mean, that would be it. And then probably use my Kinect out there to take my face and 3D print my face, just because. Who doesn't want that peering into them when they wake up? That would be excellent. Just on the shelf, just to
How about a bike helmet that fits?
You could definitely print those.
Yeah.
Definitely print those. And it'd probably be safer than a bike helmet.
Indeed. I don't want to talk about it.
Anyone else?
Colours from face so we can hack his iPhone.
So we're developing our film currently this moment into the invasion. We're looking at getting them done, and it'd be good to make some around it, at least we can tweak it a few times, and they'll go, right, that's what we're going to do, and then get it injected molded, prototype it. That doesn't mean all their 3D printers tomorrow.
Neil already has, I can see it on his face. Yeah. I've got space on my bench, just saying.
Yeah, so very lastly, I just wanted to say what I 3D print. and this is Optimus Prime as a dog.
Yeah.
The 3D printed Optimus Prime dog costume. That's the coolest thing I came along across.
Do they come in larger sizes?
You just need a larger printer.
Yeah. Not for the kids, for me, I'm telling you.
Okay, great. Thanks very much.
Sorry, quick question.
Oh, yeah.
Other than the I think it's do it for you, is there any other publicly available 3D printing services you can look?
Yeah, there are. There's one that do mainly architectural work, but they'll kind of print whatever you want. But you get these small kind of like startup companies that'll do it. And there's ones that you can, I looked it up earlier to see if there was, and there's one called Hobbs, and they do it apparently, but mostly for architectural work, and then a few little small ones as well. So you can design something yourself in CAD, or get some kind of a 3D scan, and then just get it printed by someone else. And they tend to have higher tech machines as well than most of us could afford, so that's really cool.
There's a really cool company called Razor Labs. The way they work is they basically hire people in local areas to print things that they get based out in London. So they've got places in Newcastle, Sheffield, they've got some in Leeds, Manchester, where they go out with up to the collectives. So you can go and send stuff off to them and it will get made close to where you are and sent to you. Which is
I know there's it's like I think it's called Do on Wednesdays. So they have access to
Adrian,
There's one in UHQ in Man Island, familiar with that place, a big black building. They have a big 3D, they have a 3D printing room. Sponsored by Barclays, so it's all, you get your first one free. I think he was saying you do it for free.
That's really good.
Quite a few of them around it.
Yeah, definitely. Any other questions?
Great, thank you very much. Excellent.